Hello everyone, welcome to another Leetcode video. Today we're looking at the problem minimum amount of damage dealt to Bob, which was question 4 in Biweekly Contest 138. So we're given an integer power, and we're given two integer arrays, damage and health, and these both have a length of n. So Bob has n enemies, where enemy I will deal damage I points to Bob every second, while it is alive, while its health is greater than 0. So every second, Bob will choose one of these enemies and he will deal power damage to it. But this is after all the enemies deal damage to Bob. So we want to determine the minimum amount of damage that Bob will take before he kills all the enemies. Looking at this example here, we see power is 4, our damage is 1, 2, 3, 4, and our health is 4, 5, 6, 8. So our output is 39, which is the minimum amount of damage that Bob will take. So first, we attack enemy 3 in the first 2 seconds. So from this, we're going to get 20 points of damage because in these first 2 seconds, we have all 4 enemies alive. Their total damage is 10. So before we kill that first enemy, we're going to take 2 rounds of 10 points of damage. But then after this, enemy 3 will be gone. So then we're going to focus on enemy 2 after this. So for the next 2 seconds, we're going to take 6 points of damage each because we've eliminated the 4. So now we're taking 6 points of damage each turn. So we're going to take 2 points of 6. Then we're going to focus on enemy 0. So we're going to, for each turn, take 3 points of damage because we've eliminated 3 and 4. We're going to take 3 points of damage, and then we're going to focus on enemy 1. We're going to take 2 turns of 2 damage, and overall get 4 points for that. So if you add all that up, we're going to get 39 points of damage overall, which is the minimum that Bob can take. So let's look at an example and see exactly how we can solve this. So during the contest, I was trying to throw a lot of different ideas around. I was originally thinking we could do some kind of dynamic programming, right? But then I realized that our constraints are a bit too big for this to be dynamic programming. So say, for example, we want to just pick any random number, right? Say we pick the first enemy and decide to attack that one first. Well, then we have to do this kind of recursive tree where we simulate attacking this enemy, getting rid of it, and then doing all the other ones. But then we have to deal with the other situation where, say, we don't attack one first, we attack 2 first, and then we have to deal with these remaining elements. So you can clearly see that we'd have to get into every permutation of enemies, right? We'd have to try each one first, then each one second, each one third. So we're basically doing n factorial work to do this, trying every single permutation of enemies, which is not really feasible for DP in this case. So that kind of made me realize that there must be some sort of greedy approach that we can use to solve this. So for the greedy approach, we want to figure out some way that we can optimally choose the right enemy to attack. And how do we do this? Well, you might think, for example, we want to pick the ones with the largest damage first, or maybe the largest health first. You could try these out, but you'll run into many cases where you see that this is actually not the right way to go. And what we actually want to do is think about the rate of damage that we're receiving. And we can use a certain ratio to determine this. So let's call this ratio R, so we can have our ratio is equal to our damage divided by our health divided by our power. And essentially, what this ratio represents is a constant that we can use to determine how much damage this enemy will cause us while it's alive relative to other enemies. So let's kind of walk through some examples and see exactly what this looks like. Let's say we start with this enemy with a damage of 4. So the ratio here would look like 4 divided by the enemy health over our power. So this would equal out to 4 divided by 2 equals 2. So this 2 doesn't really tell us exactly what this means. It's not relative to exactly the damage it's causing. It's not really relative to its health, but this is just kind of a value that we can use and rank it according to other enemies and see which one we should prioritize first. So let's go to the next example. So we'll have 3 damage over 6 health divided by 4. So for this division, we're going to round it up to 2. So we'll have 3 over 2, and this will equal 1.5. So let's go to this enemy with 2. So we have 2 damage divided by 5 over 4. So this will round up as well. So we'll do 2 over 2 equals 1. And then we have 1 divided by 4 over 4. So this is equal to 1 over 1, which equals 1. So you'll see here we kind of have a ranking now. So we see that we'll have this being the highest. So the amount of damage over the amount of time will be the highest in this case. So this means we want to deal with this enemy first, then this enemy second. Then we could do these enemy in any order because these both equal 1. So it was kind of difficult to come up with this ratio during the contest, but essentially this signifies the amount of damage over time that this enemy is going to deal us. And we want to always deal with the largest ones first and eliminate these, and we'll see that this is actually our optimal answer. So what's the time complexity here? So we're first going to go through these arrays and just generate that ratio, which is O of n. And then what we want to do is we want to either sort these so that these ratios are in a certain order, or we can use something like a max heap to always prioritize the max one. Both of these will be O of n times log n. Doesn't matter what you choose. You could do either a heap or you could sort it, but essentially our overall time complexity will be O of n log n because we have to sort by this ratio in order to choose the optimal enemy first. So let's hop over to the code and see exactly how this is solved. So the first thing we're going to do here is set up our array that we're going to use to optimally choose the enemies. So I'm going to call this D and H. And what we're going to do is we're going to go through every element in these arrays, and we're going to have each element be a tuple where we have the damage, the health, as well as that ratio that we talked about. So you can see that it's damage I over that amount of time, which is health over power rounded up. Then we're also going to have our total damage, and this represents the amount of damage that Bob is taking at this time. So then we're going to sort this by the second element, which is the ratio, and have it in reverse order. This means that our array is going to be sorted with the highest ratio as the first element and then descending from there. Also, our min damage represents our answer that we're going to add to as we go through. So we're going to go through each element in our array, and the damage that we're going to take in this round is going to be the total damage times however long it takes to eliminate this current monster. So you'll see the total damage is the total damage of the array, and we're going to add onto our damage however long it takes to kill this monster. So once we kill this monster, we're going to decrement that from our total damage because this monster is no longer dealing any damage to Bob, so we don't have to recognize that damage any longer. So then at the end, we just return our minimum damage. So let's submit this and make sure that it works. And then we'll submit. And it does work. So this was not a terrible problem, but figuring out the invariant for how exactly we want to sort this was definitely tricky. So hopefully this made sense and was helpful. If you liked the video, please like and subscribe, and thank you for watching.